All right, everybody, if you want to take a seat, we're about to get started here. So I want to start by respectfully acknowledging that we are currently on Treaty 6 territory, which is traditionally the lands of the First Nations and Métis people. So welcome, everybody, to Ideas on Tap. So for today, what we're going to talk about is the Thoughtworks Technology Radar for 2019. How many of you are familiar with what that is? Like with a show of hands. Has anybody ever heard of that before? Okay, we've got a few people that have heard of this before, so the question you're going to ask first of all is, what is that? And then maybe the second question, or maybe even the first question is, why should I care? And so there's a whole bunch of companies that put out things called tech radars or what's coming. Deloitte has their, their technology predictions. There's a lot of these groups, and basically what they're about is what's happening in technology. And so I think one of the pieces that they're really useful for is to provide you that situational awareness of, what's happening in my industry beyond the closed doors of where I work or what I'm taking for school. Because, for some people, you're going to find that like the particular area that you work in is all that you see. And there's actually a lot of innovation happening in a lot of spaces, and so these kind of things can help to broaden your perspective. I had the pleasure of attending a security summit in Seattle this week, and one of the speakers got up and she said that her talks she gives are across the container space and across the security space. And she said that this year when she went to Velocity, which is a pretty big conference around agile software and containers, she brought up the topic of Kali Linux. And how many people have heard of what that is? So we got a few hands. I guess everybody's hand should be up because for like a long time, that's been the standard Linux distribution that security personnel use for pen testing. So it was actually interesting. She said that when she went to DerbyCon later that year, what happened was when she mentioned that, everybody in the audience couldn't believe that there would be anybody in software that hadn't heard of Kali Linux. But at the same time, at that same conference, in a show of hands, very few people put up their hands knowing what containers were. So it's kind of interesting that by going to these different conferences, there's a lot of segregated knowledge. And so what you'll find is something like this provides a broad view of what's happening in our industries from a group like Thoughtworks that's basically a software consulting group. So that's kind of where it starts. And it's also, it can help you to focus on some of those areas that are maybe outside of what you deal with every day, but then help you to maybe say, what should I focus on, rather than, hey, let's learn everything about everybody. And the other part is it's kind of fun to read about new technology. So that's what they're about. There's a couple companies that make them, and this is one of the ones that we've found pretty helpful. So with that, I'm going to introduce our first speaker here, which is the, he's the other Dale at Vendasta, and that's what he calls me. Thank you.
Cool. So the other Dale's a better title than the ambiguous Dale duo, which is sometimes what we have going on here. Today I'm going to talk about 4 different topics that are within the 2019 Thoughtworks Tech Radar. So first off, let's look at how the Tech Radar is structured. We have this center mass here, and it's split into 4 quadrants. We've got techniques, tools, platforms, and then languages and play and frameworks. So you can drill into any one of those, and they break down 4 topics within each of those as well. So they have a number of technologies spread out over these 4 categories. They'd be hold. These are things that they don't recommend doing. They tend to be time sinks. They tend not to be worth your while. They tend to be technologies that aren't actually going anywhere or going to provide you benefits over the long term. We've got things that are assess, which they're saying are things that are coming, things that you may want to put some effort into. You may want to be aware of these, and they are kind of the future of where we're going to dedicate our time within technology. We've got things that are trials. Trial falls into if you have the risk capability, if you have the time to put into them, they're probably going to bring you some benefit in your software environment. You want to spend some time on these when available and when you have the capacity to do so. And we've got adopt. These are technologies and techniques that they say you should be doing within any of your organization, and take advantage of them when you can. So specifically for this talk, I'm going to talk about 4 things. 3 of them are in the trial category, that being multi-account cloud setup, observability as code, the run cost as an architecture fitness function, which is a big mouthful, and infrastructure configuration scanning. So starting off, multi-account cloud setup. I'm going to walk you through a little scenario here that we see fairly frequently. We've got a developer at Vendasta that wants to try out some new technology, has a problem that they're trying to solve. or wants to work on some solution. So let's say this account at Vendasta wants to send emails from an application. They have reports that they need to send out. They want to ask for reviews. They want to do something along email. The most popular pattern for that is to use something like SendGrid here. So that account goes to SendGrid, signs up for a free trial, creates an account, gets a set of API credentials, and it builds their thing that they're going to execute. They want to send email. It doesn't take long before they start sending more emails than the free trial has, and they put a credit card in. It doesn't take long after that other people see how easy SendGrid was to integrate and start asking for those API credentials to build their own applications and their own features. So now we have a situation where we have an account that has access to SendGrid and can send emails, and that's used in multiple places. How do we share access to that account? Sometimes it ends up pinned in Slack channels, it gets shared in Google Drive, it gets sent out in READMEs, wikis, and everybody shares that same account. The problem here is we have all of these people, whether they be designers editing templates, support trying to figure out who emails actually went to and what was in those emails, developers trying to build their own features on this, and we're all sharing an account. This is not the ideal setup for how we actually build features. You've got people that are in an account that have more powers than they should have. There's accidents that happen when you delete something, when you change something, and unintended consequences. So what Thoughtworks is saying with multiple account setup is be specific in what you're trying to do with an account. So if you're going to use SendGrid for an application, have an admin make an account for that. Build different roles and different accounts for each of your use cases here. So build an account for support, build an account for your developers, build an account for design, and at the very highest level, do it at a team. Ideally, you do this individually with roles, but do it at least at a team level where you can have access to only what you need access to, and split these things out by their application. So for somebody like Vendasta, it's probably not unusual that we would have 3 or 4 accounts. There are downsides to this, like billing. You might end up with 3 or 4 bills, but typically how that works itself out is by having only the package size you need and features you need on each one of those bills. The upside here is it makes it a lot easier to figure out what the cost of goods sold is. You can actually see what each application is using within that scope. If an application decides that SendGrid isn't the right choice for it, they're not locked in on that. They're able to move that application's usage to something else. We don't have to commit to using SendGrid forever. It's not like it's so ingrained in our application that we're stuck on that. Let's look at another example of multi-account setups. That's the Google Cloud Platform. So we've got the Google Cloud Platform, and we've got an organization of Vendasta. Within that organization, we've got about 100 other projects. So every project owns its own IAM and permissions. Every project owns its own API quota, the products that are enabled. Every project gets its own bill broken down by what exactly that used. So instead of having the pattern of putting everything in a single project, what we want to do is break out our projects by their functions. This allows our teams to have more control. Something like Website Pro can have its own project, and the developers on that project actually be an owner, make their own resources. We don't have to worry about what is going on. If they have the ability to make resources in a different project, we can limit that scope if an account gets compromised. There's also benefits with our API quotas. If one person is being a noisy neighbor, uses all of something like pub sub admin operations, it's not going to prevent another project from actually starting, being able to load its applications. It lets us have really fine-grained control over what products are enabled so that there's less risk if something happened like a compromised account or the ability to start up applications we're not expecting. It also makes us less sticky. So if Website Pro decided tomorrow that they were going to move from Google Platform to AWS, it's a lot easier for them to move out of a single project into a different provider than it is if they need to extract things from a shared Kubernetes cluster or from shared resources and move that away. And one final benefit, cost of goods sold is a lot easier to calculate if you just look at the whole project and say they spent $7,000 last month versus they spent 4% of a shared value and used some resources over here, and we take a guess at that instead. The second thing I want to go into is observability as code. So this kind of comes out of the classic configuration as code. If we think back to the mid-2000s, the big thing was configuration as code. Instead of somebody starting up a server and running all this manual configuration through either a command line or through a UI, we were now able to make that configuration through scripts. Committing those scripts allows us to actually version them, to have peers review them, to be able to see what is actually being applied to the server. That removed a lot of the magic that came from classic sysadmin roles. Following along that was the infrastructure as code. Once we moved to the cloud, we were able to not only apply configuration to running servers, but we were able to actually provision those servers with code and say, I need a resource of this size configured on these networks with these options like hard disks, and say, spin this up for me, and it's just there. Again, it reduces the amount of wastage. It reduces the amount of knowledge that you need to have to spin those things up. If you decide to move a resource, you're able to just do that by configuration and scripts. Observability in code is the next big thing. So all the things as code is the goal here. So once we have configuration done, we're able to spin up a new server running that. We want to be able to actually monitor that server and see what's going on within there. So here's an example of a dashboard that we would use here at Vendasta. So in here we've got a dozen graphs that tell us what the latency is on any given dashboard. We want to know what the traffic looks like, what the success and failure rate is, the number of requests per second, the most popular paths, all of those things that make it easy to monitor a microservice and see what's going on within it. But it's really cool to see these insights and build it the first time, maybe the second time, but we're at like 95 to 100 microservices now. That's not scalable to build that graph individually every time. What we find is we have problems with math. People decide to make a graph and do a sum instead of an average. We see inconsistencies across almost all of the graphs. Everybody builds kind of their own view for it. We miss important things like 400s, 500s, all those different things. So what we actually want to do is have our observability be part of our code base so that we're able to commit those things, be able to make version changes to them, have our peers review them to make sure what we're actually displaying is what we're expecting, and even move on beyond that to alerts, figuring out ownership, figuring out how you can actually tell when something is broken. So here's an example of how we would build a dashboard that I just showed. For any given microservice, we'd use our microservice command line to say mscli app Datadog. What that's going to do is generate a default dashboard with everything that we've programmed in. This lets us either update an existing dashboard or overwrite an existing dashboard. We store a configuration item for which dashboards have been created for an individual service. And that lets us take this service and know what its dashboard is, so we can update it, we can overwrite it. We decide we want to have a new set of graphs that we add. We can commit those to our shared library and update that across all of our sites. And one further step is the ability to identify who owns a dashboard or service, what the availability level should be for that, so we can go beyond just making monitoring to watch those things, but actually have alerting, know who to alert, know what dependencies are in individual services. And we want to commit all of those things at code so we can automate the workflows around them. Here's an example of what one of those dashboards look like. I swear this is the only code I'm going to put in my presentation. But it basically shows the queries that we use to generate those things. So we're just going to sub in our Datadog name. Datadog's the service we use, which is going to show our service name and graph the latency. So this would be the example for one of those graphs. So we'll have 30 or 40 of these, and that'll generate a default set of graphs for any new service that we spin up so that we can make sure they're consistent with the other ones. And we're able to actually see what goes on with any new service we spin up. Beyond that, our goals for this is to make monitoring and alerting turnkey. It's easy enough to spin up a new service, but we don't want to have individuals going off and making their own things. We don't want to have inconsistencies across our system. We want to make sure that anything that we graph out is peer-reviewed so that we know actually what we're displaying. We're not making false assumptions by it. We want to make updates easy, so when we discover a new valuable graph, let's say it's showing how many load balancers are in use and if they've scaled up or scaled down, we can add that to our shared library and apply it to existing sets of dashboards. We want to make sure our alerting actually matches our targets, so that if we develop a set of monitors and a set of alerts that go off of those, that they actually reflect what we're shooting for availability within that, and they notify the right teams. So the important thing to take away from this is that when you pick a vendor for your displaying of graphs, your monitoring, your alerting, pick one with APIs, because at some point you're going to want to actually automate most of those solutions. Second one I want to talk about here is cost as an architecture fitness function. This is a big mouthful, so I'm going to start with the goals up front here. So the goal here is to empower teams to own their own costs. You want your teams to be able to monitor the cost of their running applications at any time and easily. There's a big assumption when you move to the cloud that costs are going to be cheaper because you're only paying for resources you're actually using. You're only paying for server cycles while you're using them. That's not necessarily the case. Most cloud providers are pretty good at charging you for what you're actually using and getting their resources out of that. So you want to make sure that you track the value that you're getting from most of your resources and compare that to what you're actually paying for it. And when there's a discrepancy there, you invest the resources you need in order to make sure that that discrepancy is taken care of. You also want to make sure that you're able to spot problems before they become big. In a serverless environment, it's really easy to start spending money that you're not aware of and to have that scale almost infinitely. So let's say you have a really high-performing application that's able to perform a large amount of load. That also comes with a big price tag on it. It's very easy to become spinning resources. You're not actually going to see errors on your client side because they'll just auto-scale in the back end. So the more traffic you see, your customers are still able to see what they need to see, and then all of a sudden you just get a big bill at the end of the month. Let's look at a couple examples from Vendasta's environment here. This is Cloud Spanner. So Spanner is a distributed database. It's highly available. It's extremely performant, but it doesn't have any ability to scale. You pick a static number of nodes that you need, and it provides you with those resources. So for the long time, we had run 8 nodes for Spanner. It ran us about $280 a day to run those 8 nodes. And that basically handled our peak loads. So when we ran backups, when we ran large ingestion jobs, it would need 8 nodes in order to do that. The majority of the time, some of those nodes sat almost empty. We could get away with 5 nodes, 3 nodes even. So we did the math to figure out how much we would have to spend in order to find a way to do an autoscaler for it. So looking at our CPU resources, we were able to scale down Spanner on our low usage times and actually scale it up during our peak usage times so that we'd be able to handle even bigger spikes. So we ended up spending time on development for an autoscaler for Spanner with our own solution. This lets us run 5 nodes normally, which saved us about $75 a day. But when we do something like a bulk migration or a bulk import or run a heavy load, we're actually able to go up to 8 nodes. So we get a lower cost during the normal time. We're able to handle 40% more capacity, and it saves us about $20,000 a year by writing that code. If you factor that it took a developer about a week to develop that solution, that pays off significantly. So what they're saying here is use cost to determine what you should be doing in your backlog. Determine if the solution that you've chosen is correct or if it needs to be refactored in order to save money. Here's another example of an application in our environment that over the course of January ramped up its cost. Normally it was a few dollars a day. By the end of January it was running at almost $60 a day. What happened here is we had failing tasks within that application. So every day more tasks would be added, every day more tasks would fail, and the application just auto-scaled itself in order to handle all those additional tasks. By the end of the month when we found it, we had about 18,000 failing tasks in this application. Our customers didn't care. They still saw the same normal response times that they always did. But this application was just costing us more and more money every day because of the number of tasks that were failing. If you have teams in a serverless environment, watch their costs closely. You're able to catch these things before they become thousands of dollars. The last one I want to talk about here is infrastructure configuration scanning. This isn't in their trial stage. This is something that they're saying is coming down the road, and if you have the opportunity to spend some time and effort into, it may have valuable insights to your organization. So the tool that I've looked into here is Forseti for security. It's an open source tool for scanning GCP projects. It has 4 main goals here. The first is to keep track of your environment. It does inventory of all of your assets in the cloud, so it tells you what exactly you're running in which projects and of what resource size. From there, it gives us the ability to monitor policies, so you can write a set of rules and evaluate your resources against that set of rules. Let's say we have something like a Cloud SQL database, and we want to make sure each of our Cloud SQL databases are using SSL for security. It'll look at every database we have and show us all of those violations that we have in that case. This allows us to default to open, allow developers to create resources, allow people to experiment and try new things, but at the same time audit our system to make sure that things are in compliance. It allows us to enforce rules. So there's an enforcer portion that will remove cloud resources that don't meet its requirements. You may want to do something like this for cloud storage buckets that are open to the internet. Check your entire repo for cloud storage buckets. If somebody's made something and opened it to the internet, you have the chances that people are going to take advantage of that. They're going to delete resources. They may find stuff that they shouldn't have access to. So you can enforce rules on that to actually take away the permissions or make changes to those buckets if you end up having a mistake in there. Another one is understanding your policies. As good and fine-grained as Google's Cloud IAM is, it's really difficult to see who has access to exactly something. Given the number of roles and overarching roles you can have and individual permissions applied, you can't really say, does this person have access to this thing? Or show me the things that this individual person has access to. Forseti allows you to take those rules and a user and do kind of a mesh on them and see who has actual access to any individual thing. The other one that's coming out recently is Google Cloud Command Center. It's in beta right now, and it does a very similar thing. It does inventory of all of your current resources. So this is an example from our Vendasta repo. We've got about 45,000 compute engine images, the number of disks we run, the number of compute resources we run. This allows you to actually know what's going on in your system, and on any given day, know which things are new, which things were deleted. You can spot problems in your architecture and problems within your applications by some of these changes of new and remove things. It also plugs into other resources like Stackdriver, your Forseti, and any of the security scanning for like container images, and shows you what things have changed within your organization, new vulnerabilities, that type of thing, all from one main architecture point. So the goal of infrastructure configuration scanning is to default to open. We want developers to experiment. We want them to spin up new resources, but we want to make sure that those are done in a consistent way and that there's not risk introduced to our organization by them. Auditing is a really key point in any security aspect, so we want to make sure that audits are done on a regular basis. We know what's changed, we know the rules that we've written are enforced, and we want to know when new resources are provisioned. They cost us money, they're potential weaknesses and open spots in our organization. So spend some time on infrastructure configuration scanning. There's a lot of things that could be coming in the future, and this is going to be a point that becomes more and more important down the road. So those are overviews of 4 key kind of points within the Tech Radar that I noticed and thought were important. Are there any questions about those that jump out at anyone? Awesome. That's me, and Dale's going to come back up.
All right, I forgot to mention about the 50/50 tickets we've got on and the drink tickets you've got tonight. All the proceeds, they go to charity for this, and specifically today the charity is JDRF, is the Juvenile Diabetes Research Fund. And so this is a group that, it's a really good cause, and they're actually on the verge of having a cure for type 1 diabetes. So that's pretty exciting. So anyway, feel free to take your time, meet other people, grab a drink, and grab some food, and I think we'll reconvene at about 5:20. Thank you. All right, everybody, if we can get you to take a seat, I'd like to introduce our second speaker of the evening. His name is Kevin Sokochev. I think almost everybody pronounces that wrong for years. It takes a little practice every time. But I put a picture up here if you want to learn more about Kevin. You can write down how to spell that. But once you get two O's, a K, another O, it actually auto-completes in Google for you. And as a bonus, there's Kevin's talk for today right there on his blog. Kevin's always writing about stuff. He's a really smart guy. He's a former Vendastian and currently a senior architect at Workiva. Please welcome Kevin.
Thank you. All right. So it sounds like this mic is working, so that's a good sign. Yeah, that's a little bit loud. Okay. So a little bit about me to start. My name is Kevin, as Dale mentioned. I'm kind of in the middle of a Dale sandwich here. There's Dale at the front, Dale at the end. I'll leave the visual there. You guys can auto-complete that, as Dale said. So I work as an architect at a company called Workiva. We have a small presence in Saskatoon. There's about 13 of us now at our office. And we have a larger presence. Our headquarters is in Iowa, Ames, Iowa. It's like the North Battleford of Iowa. So apologies to anybody from North Battleford or from Iowa, either one. So as a company, we're about 400 developers, I think about 3,000 employees now. So then what we do at Workiva is we build really financial reporting software. So it's like you sell this software to chief financial officers and their employees so they can accurately report their numbers, file their reports that they need to do with the government, stuff that I know nothing about. And I'm more of a technical person. And my interest in the technology radar is actually as part of an architecture role. So when Dale said that that was the subject of this session today, I was really kind of interested and excited because we're actually working on developing that for our organization at Workiva. And so as a architecture problem and as an architecture group, it's really trying to figure out how to allow autonomous teams to make good decisions that still fit within a larger framework and platform that you're trying to build as a company. So the tagline that we're using within our architecture group is like innovation with constraints. And we've had the previous problem before where everything was just like total autonomy. People could just make whatever decision they want. And then after we got to a certain point, it's like this is not able to scale because our operations team is really completely overwhelmed by all the complexity. There's a bunch of different tools used in different places. And so what we're trying to do is rein that in a little bit by offering some constraints. And the technology radar is a great way to do that. So we're in the process of developing one for our organization where we say, like, this is the list of approved technologies. You know, my responsibility right now is largely APIs, which is the subject of this talk, and our third-party platform. And I keep getting asked about GraphQL as like, okay, can we use GraphQL? And this is a great way to say no, really. It's like, I'm aware of GraphQL. We all know it's there, but for now, it's in this hold box. It's something that we're not going to do because we can't effectively deliver our APIs that we have a backlog of right now. So until we can actually get that done, let's put GraphQL on the back burner. But just being able to have that visual or being able to say, yes, I've heard you. We're aware of this. You know, it's something that we're thinking about. That's enough for people to feel happy and satisfied. Whereas if you don't have that artifact, and the technology radar is great at having that visual representation, then you have to have that conversation again and again with different people throughout the year. So I see a lot of value in this, and we're trying to adopt that at Workiva. So that's kind of a prelude, I guess, to the actual real talk. What I wanted to talk about today is API gateways. I forgot where my clicker is. There it is. Okay. So the talk is kind of like there's a few parts. It's really like what's an API gateway, and then why would you want to use one, and what should you not do when you're using one. So this is an interesting one. It's not specifically on the technology radar, but it's in like their preamble of enterprise anti-patterns is leveraging these API gateways too much. And I'm going to talk about what that actually means. So first, what's an API gateway? At it, very simple, it's a reverse proxy. It sits between clients and services. So what that means is that the proxy, the gateway, is responsible for actually making the request to the server and returning the response. And so from a client perspective, they're talking to the proxy, and they don't actually know about the services that it's talking to behind the scenes. Now, the bigger question is, like, why would you actually want to use one? And I'll run through an example to help illustrate that. So imagine you've probably all been to this website, Amazon. There's a book details page, and you're wanting to actually assemble this page for as a developer. So you've got your web client team, or potentially the back-end service teams that are implementing this. And I'm going to walk through, and every star is potentially, if you're building a microservice type architecture, is a different service that actually provides that data. So here, like the in stock is maybe a service, and there might be one for listing like how many other sellers are there. You can click through and see more. The basic book details, like the name, the title, the author. They have data about me on there. That's the wrong postal code, but that's okay. Seeing all the buying options. There's more and more of these, and each one of them could be their own service. So here's a list of potential things that you might want to be building or might need to build to actually assemble that page. And so looking at it more from like an architecture perspective or from like a system perspective, you have this user interface, and it's making requests to multiple services to actually build the thing. So this is actually potentially problematic, because what you end up with is this coupling between, I'll go back one, between the user interface and multiple different services. So here there's 4, there could be 8, there could be 10. And so that client needs to know about the endpoints for each of them, and they might be a different domain name backing those. There might be any number of things that they need to know the details of. And they need to know, like, we need to answer the questions of what happens when you introduce a new service, and then the client has to be reconfigured to point to that new one. If you change one of the services, if you split a microservice into 2 or do a large refactoring, then all your clients have to be updated too. There's also like shared concerns, authentication, handling SSL termination. Does every service need to do that? Handling rate limiting. If I go back previously, if I can, there we go. All those different services have to implement that. And also multiple protocols. Maybe one of those services is a legacy one, it's got an XML payload, and one of them is newer, it's got JSON payload, or anything in the middle. So the answer to that is that you'd use what's called a gateway, and that is that reverse proxy, and it's very simple. You just sit that in front of your services. And now you've got this one endpoint that you would use, and that endpoint sits in a very unique position in your system where it's really, it's a single point of failure, so you have to be aware of that, but it also has access to all the different traffic from the client. So you can start to leverage that to do a lot of different things. And you can do a lot, so there's a lot of functionality that you can jam into the gateway, and I've divided it here into 3 different overarching patterns. Routing, what I call offloading, and aggregation. So routing is really that first example, using the gateway as a reverse proxy. So what happens there is requests are routed to your backend services, and you can use layer 7 routing at this level, so that's the HTTP payload, so you can examine IPs, you can examine sessions, whatever's on the headers. You get cookie access, that kind of stuff you can use to route requests to different services. So you can use a lot of rich data about your client to route it to the right backend service. An example of that is even having 2 clients using the same gateway, but directed to 2 different backends. If you have, for example, a mobile client that doesn't need the full set of data that the web client needs, they can go to the gateway using the same initial interface, but be routed to the correct backend service or be returned the right response. Again, the bottom point is really the key one, is that it's trying to decouple the clients a bit from the services. So this is an example of that. I just put it's the same diagram, but just having that explicitly the layer 7 routing in there. The second point that kind of broader pattern for API gateways is what I'm calling offloading. And so because of the unique position of that gateway in your system, having all that access to traffic, you can do a lot of different things. So the first two are SSL, like termination, and authentication. And those are good examples. Maybe you don't want to actually use those in your architecture, depending on how you divide your security domain. But the point here is that you can actually leverage the gateway to do things so that your services don't have to do them all themselves. So if you have 8, 10, 15 microservices in one client, then all that common functionality can be implemented at the gateway. So the one that we've used is client-side rate limiting. So at the gateway, you can actually use that layer 7 information, like an IP address or a session token, and use that to implement rate limiting. And then the services that you're backing don't have to do that and implement it in every different language that you're using or every different system that you're deploying. It also, issues like logging and monitoring, you can add that at this level. Start to cache responses at the gateway level. So Amazon's API gateway is a good example. So this is a commercial product that you can leverage to do this stuff. And if you use Amazon's API gateway, it's globally distributed using their CloudFront CDN. So any responses that you cache using the gateway are going to be really fast no matter where anybody is in the world, because it's got that global CDN as part of it. You can even do something like adding compression to your responses at that gateway position and not having every service have to implement that themselves. So this diagram, someone got their head cut off. That's okay. This is an example of the SSL termination where if you have a secure boundary for your security architecture, then you can implement that SSL termination at that boundary using the API gateway. So this is useful as an example, but I would exercise caution here. I think this is not necessarily best practice now. I think you usually want to have your services implementing SSL and authentication regardless, but this serves as a good illustration of what is possible. The last pattern is aggregation. So back in the previous example, we had one client making 8 different requests to actually assemble a page. But you can actually leverage the gateway to reduce the amount of traffic between the client and all those services so that the client can make maybe one request and you can aggregate the different responses from different services and return that back. And that's actually similar to the GraphQL ideal. And the goal here is kind of reducing chattiness between the client and the backends. And you also get a secondary benefit or a secondary option, I should say, is transforming the data model. So you might have an internal representation of your data. It could be gRPC that you use or Thrift or some other RPC framework. And maybe the representation of your data isn't exactly RESTful, and you need to expose a REST-based API to a partner or a third party. You can use the gateway to actually do that for you and not having to actually implement that every time. And you can also do stuff like transform the JSON payload to change the name of a field that you maybe internally you use VID for Vendasta ID, but externally you don't want customers to know that that's what it's called. So you just call it ID or something like that, right? Everybody does that. It's like we have probably WID at Workiva. It's like something super specific just for you. Excuse me. So here's a good example where you have one request rather than 4, 5, 6, or 7. So you make one request to the API gateway, and that actually assembles and returns a response. And you can leverage the payload transformations. You can do caching there. So this is going back to the original point, is like, these are all the things you could do, but should you do those things? And that's the point of the Thoughtworks kind of article, is that you might be being too ambitious if you're trying to leverage a single kind of middleware product to do all these things. So where do you draw the line? So this is the quote from the Thoughtworks Radar. Really, we remain concerned about business logic and orchestration implemented in middleware, and this results in an overambitious API gateway. So this is the spirit of the quote. It's not exact. I had to munge it a little bit to get it to fit on the slide correctly, but So it's really like you've got this central point in your architecture, and it's tempting to use it for a lot of things because it's right there, but you want to avoid overusing it. So let's go back and see of these different patterns, which ones would actually make sense to leverage and which ones you might not want to. So routing, I think, is something you would want to use for your API gateway strategy. So that allows you to version your APIs effectively, version your backend services, do refactoring without having to change your client every single time or update your client to point to multiple services. And so this gives you that decoupling, which is really the key benefit. And you can implement this with just like Nginx. You don't need a complicated product to do that. The products, the commercial products like Apogee or API Gateway or MuleSoft, what they do is kind of like start at that proxy level, and then of course it's these value-added services, and then they try to have a more feature-complete offering so that they can sell it to you. So routing, I would say that's something we want to use. So offloading, I think this one you have to be careful. So you can try to do too much with this offloading. So you can try to assume too much responsibility from all the services, and that's probably an anti-pattern. So where I work, what we've used the API gateway for is rate limiting, and we use it for initial checks that requests are valid. So we don't actually do any authorization. We don't actually do like SSL termination, but we make sure that any like obviously malformed requests the backends don't have to deal with that. So an example there is that we would check that requests have an API key, and we would check that they have a JWT token, and that's how we do our authentication is with JWT. And so we don't actually parse the data inside, we just make sure it's well formed. And if those two things aren't there, then we just reject the request. Otherwise, let it through. So you can use more different functionality or from the API gateways to do more, but you just have to be a little bit cautious. One other thing we do use is caching. So you can leverage the globally distributed CDN that's provided. So the last one is where I would say you might want to hold off, and this is where it gets to that idea of being overambitious. So what you do when you end up doing this aggregation is you're taking business logic that is more accurately described in code, which it goes back to like Dale's point that everything is code, where you've got API gateways that you can combine responses from multiple different services, or you can send a request to the API gateway and it does some complex orchestration procedure where it calls one service, gets the response, and then if this, then call that. And all those different products allow you to do that, but then you end up with this complex business logic that is in this middleware that is configuration based. So you can think about trying to set that up in XML or in like some sort of configuration language like YAML, and which is even worse probably. But the whole thing is that you're taking this stuff that should more likely be testable with unit tests, with your really software development best practices, and putting it into this middleware that you have less control over, makes it difficult to test. You can't really debug it. And what happens is these APIs are going to be used by third parties. So this becomes, at the same time, like untestable code and critical stuff. So you're at this really unfortunate spot where you don't want to make any changes, but you also don't fully understand it because you get all this complexity built into this long XML file or YAML file or whatever. And if you've ever used like Spring or something, you kind of can understand the pain that might cause if you have these thousands of lines of XML and you're trying to understand it. So I would say no to that. And this is my quote, so you can quote me on this. Just keep logic out of the gateway. That's really the overarching theme of this talk. So just kind of recap, what have we learned, what have we talked about, is that API gateways are an important piece of your function of your infrastructure, or they can be. And they do serve a lot of good purposes, from decoupling your clients from your services. But there is a caution there to not overuse them to do more than that functionality. Excuse me. And that is what the Thoughtworks Radar is cautioning against as an enterprise anti-pattern. I'll take questions now.
Hello, hello. Awesome. Great presentation. I just have one quick question related to kind of dealing with unauth versus auth traffic. Do you think, in terms of a technical implementation, do you think it's actually better to potentially have two different API gateways, one that deals with routes that are authed and one that deals with routes that are unauthed? Or do you think it's better to actually have that as kind of like a sub-route under the main API gateway to actually divide it? Or is there some other method that's better? I'm just curious how you would deal with that problem.
So I would recommend, and I'm not a security person, so take this with that caveat in mind, but I would recommend that the API, that all the traffic that's entering your VPC or your private cloud or your network, within that you treat it the same as you would external traffic. So I would not terminate SSL connections at that gateway level. It's possible, it's an option. Let me step back. So one of the things with the gateway that's difficult if you have multiple services and multiple domains is managing certificates. And there is a lot of complexity with SSL, but I think that there's a lot of benefit to having your services implement that security boundary. And then that's more of like a zero trust model for security, where you don't trust internal traffic either. So all the services implement all of the security best practices that you would if you were public facing. And so that is what I would recommend. I think if you were going to draw a line like a little bit more flexibility, I would say you can terminate SSL at the gateway and have unencrypted traffic locally depending on what you're doing, but still make sure you validate whatever authorization scheme is entering your services so that you can actually make sure that they have correct authorization even though they're internal traffic. I don't know if that answers your question directly or just walks around it though. So if it doesn't, yeah. Because I think for having two separate API gateways, for secure and unsecure, I think I would say no would be what I would think. But again, I'm not a security expert, so.
Okay. Perfect, thanks.
Okay.
So that question about the VID into the ball. Oh, there we go. Oh, so it's not just decorative. Oh, that's awesome. So that joke about the VID seemed a lot funnier to a couple people in this room than to the rest of us. Is there something deeper going on with that?
I have no idea.
Okay.
I don't. Maybe there is. I just use it as an example. So at Workiva, we have all sorts of that stuff. We've got like WIDs and whirls and stuff. And it's just like, someone has this idea and then it's like, oh, I know, I'll call it W whatever. And so I just thought there's probably a V whatever.
Okay.
So it was just an assumption. Maybe there is more to that story. Someone else can chime in.
You heard burst out and laughed at the back. So at Vendasta, we have lots of our technology is called vAPI or vCache or v something. And so I found it humorous that, and Kevin worked here once upon a time ago, and he was very, very familiar with our vAPIs. So it was a very funny anecdote for me that we are talking about V things. We have lots of V things internally to the company. John actually might have a real question though.
So you touched on quickly having a single point of failure.
Right.
What's your thought about the reliability around API gateways?
That's a good question. So depending on what you're doing, yeah, there is reliability concerns. So depending on what type of client technologies you're using, you can work around that by having a pool of addresses that you would, have one and then have a fallback. But I think adopting an API gateway, you have to assume that risk, I would say, and plan accordingly. So that would mean that system has to be reliable, and you need to be able to put the amount of resources that you need to put to make sure it is reliable. And so, one of the things that I like to think about reliability is that not every service needs to have the same level, and you need to know which are the critical points and invest in them. And if you adopt an API gateway, that is what you'd need to do. I think this is where it's good to leverage the clouds. We've been using Amazon's API gateway for about a year, and there's been never any downtime with it. So that's good. I mean, it's just anecdotal. Maybe other people have. That product is very rough around the edges. It's like the Amazon way is that if something's 80% done, they start selling it, and then they never finish the 20%. And so that's API gateway, but it does work. So that's what we've got.
I had a quick one. Similar to API gateways is the idea of back end for front end. Any opinions on that?
Sorry, what was the question?
Similar to API gateways, there's the idea of backends for front ends, where it's the aggregation layer, but it's just for the one page, and just that one page aggregates it for itself, but not the general purpose API gateway.
Right. Yeah. So that's like similar to the GraphQL model, where you kind of, as a client, you ask for the resources that you want, and then something kind of assembles them for you. And I think that the analogies are very similar to what I've talked about with API Gateway, but I think that one is a lot more code-based rather than configuration-based. So I don't really have a strong opinion or experience with that, so I don't know if I'm well-suited to comment.
Oh boy. So you talked about aggregations not really fitting in at the API Gateway layer. Have you found anything that works sort of? We have this push and pull back and forth between being service specific or being at the API gateway layer, at the API gateway being very abstract. Have you found any middleware that sort of, or not middleware necessarily, but anything that sits in between, sort of like you can define on a service by service basis that acts as that aggregator? Sort of like any library, any framework at all?
The one that I know of is Apache Camel, and that is like a messaging integration. It's like enterprise integration middleware. So what that does is it helps with translating between different systems that you use. So one of the things that we've never used it, I've never used it, but I know it exists. And one of the examples that we have is we have an internal messaging system. It's called NATS. It's not like internal as in we developed it, but it's an open source project that we use. And that is a messaging bus, really. And so being able to convert that messaging bus traffic, which is encoded using Thrift, to like a RESTful endpoint, you could use something like this Apache Camel that can do that for you. We haven't done that. So far, that's just been left to teams to implement if they need it. And I think I'm still waiting for a pattern to emerge from that, I guess, of what could be more acceptable. But
yeah, that idea of something that can both hydrate data from multiple services and cache it and manage that all at one layer, and sort of being able to define that on a service by service basis. Like
right.
I'm looking for that, and I don't know that I've seen something
so
like that.
One thing that's interesting is I don't know what type of environment are you running in?
It's like Kubernetes.
Oh, okay. So I would keep an eye. I would look for Istio in the future for that. So a lot of the functionality that an API gateway provides, that offloading of like common features like SSL termination, logging, monitoring, that's going to be provided for you by the like service meshes in the future. And so we've looked at that, but it was just too early, right? There's too many rough edges. But I think that would provide a lot of what you'd be looking for. As far as aggregating multiple responses, I don't know if they'll get there, but I would wait for something to emerge rather than spending a lot of time on that, if that makes sense. I would put that in the hold of the technology radar. Maybe the assess is, I don't know which one's after that. Maybe I'm mixing up trial and assess, but anyways.
No, I think anytime we've tried to do that, we just implement it on a case-by-case basis. It's not really needed in that many cases. So
yeah. I think that's probably a good strategy for now, I'd say. Yeah.
Thanks.
All right, thank you.
Thanks a lot, Kevin. Now I've got a quick talk here. I promise I won't make you sit for too long. But thank you very much, Kevin, for coming out here. You'll notice Kevin can take the headset off. It doesn't get caught in his hair. It's wonderful. That's not true for all of us. There's a lot of benefits to having long hair, but very few of them actually come up on a day-to-day basis. Like at the airport, they actually think you can smuggle knives in here somehow, and you get extra searching. I discovered that twice in the last 2 weeks. But I wanted to talk about a couple things in here on the Tech Radar, and I summarize it as diagrams, hackers, and DevOps. So hopefully you're interested in one of those three things, and if not, I promise it's not that long. So One of the things that I like to talk about is the good old days, which, I mean, how many of you here have done a master's thesis or any educational writing? Tony, I'm glad. So then how many of you have ever dealt with LaTeX? Yeah, so this is one of those things that Thoughtworks talks a lot about, which is like, hey, let's put stuff in the code. And so what happened was, this is like 1983, someone said, you know what would be really great would be if we could describe formatting in the same doc as where we put the content, and it would make it really easy to share documents. And then the same guy said, you know what would be really great would be as if in text we could describe all sorts of diagrams that we're going to need for those documents. And again, we could describe it in text. And then somebody came up with the acronym WYSIWYG, which is what all of a sudden you got all these diagramming tools and Microsoft Word and all these great things that people love, except for that if you don't have the same program, it's really hard to share that stuff. And so some of this stuff is great, and all of a sudden we're starting to see, hey, wouldn't it be wonderful if this stuff was in code and it's a great new idea? It's really not a new idea. Like AT&T thought of this a long time ago, and universities thought of it even before then. Like the problem is with tools like Graphiz that are for writing graphs is it's super pain to install this. If you got a Mac, you can follow a whole bunch of stuff about Brew and getting a bunch of things installed, and then you got to install X Windows, and I mean, after 20 minutes, you're like, fine, I'm just going to draw it in Google Draw. And he probably didn't say fine, but that's okay. And then, you know, it's not been actively developed in a long time. So some of the newer diagrams like web sequence diagrams or things that are more modern, it's really hard to actually do those in a tool like Graphiz, despite the fact it's actually really cool to be able to store this stuff in code. So this is a diagram that we built, and you're going to find that these kind of diagrams, these web sequence diagrams, they come up every time you're talking about security or performance. Because it turns out when you're trying to improve, like you're even trying to understand security, it's one of those things where you got to write it down. And so this is basically how you transfer a user from one domain to another, and you do it securely. That's a lot of stuff going on in I want to thank the marketing department because they made this diagram, because it's like hard to draw one of these diagrams with a nice tool. Did Nolan do it? Never mind, not the marketing department, it was Nolan. So the marketing department was like, we'd have done something way flashier. But anyways, this diagram, Nolan, how much do you like it when we need to make changes to this?
It used to be easy, now I have to
yeah. He has to export it, and he has to remember how he actually made this thing. And he's like, fine. But you know, there has to be a better way, and one of our developers came up with, you know what, he found this website, and it's called Web Sequence Diagrams, and this is actually a tool that's literally built for web sequence diagrams, and you can write this stuff down, but the problem is this is a website, and you have to go to this website and type the code in, at which point it generates a diagram that's just as good as what Nolan built. Oh, wait a minute, it's not quite as good as the diagram that Nolan built. And so this is what we actually used for a while for documenting some of these less external-facing diagrams, let's say, because we actually can store this in code, and other people, they can actually edit stuff that looks like this and, you know, fix a typo or do something else like that. But then one of the things that came up on the Tech Radar when I was looking through here is a little tool called Mermaid, which, I mean, how many of you are thinking diagrams now? Yeah, probably nobody. I clicked through the whole thing, and when I saw this guy, I was like, wait a minute, this is actually pretty cool. And so if you want to install Mermaid, this is the 3 lines that you actually have to run, and if you're a developer, pretty much everybody already has Node on their computer. It's super easy to work with this stuff, and then what you can do is you can then, taking your modern computer here, you can draw your diagram up again as code, except for the output looks a lot more like Nolan's diagram in that you've got all this proper web sequence diagram stuff, and again, I just quickly wrote this so it could be a little better. But at the same time, you can actually do web sequence diagrams, and you actually do it with code that you definitely can't read there. But the important part is that you could actually update spelling mistakes, you could fix the arrows, you could fix all that stuff, and you don't need to have a background in graphics, and you don't have to do that like where you have to align the pixels, and you're spending all this time, and there's this snap to that's never actually helpful. All that stuff goes away. The what you see is what you get is really wonderful, unless that's not what you wanted. So this is one of the tools I thought was really useful, and again, if you have NPM, you can install Mermaid. It's super easy to work with, and I would recommend if you're actually drawing any type of diagram, not just web sequence diagrams, they got a lot of really cool stuff, and so if you're trying to do graphs, you're trying to do this other stuff, it's really great. And if you have a program that's like, let's say, outputting thousands of things and how they're interrelated, you can draw really cool graphs with this that you probably wouldn't bother to draw by hand, and it can tell you interesting stuff. So I would highly recommend that as an interesting thing. Now, this is another one that I thought was really cool. How many of you guys heard of DevOps? Okay, so you'll notice that when Kevin was talking about earlier, he was like, you know what, our company loves to innovate, but then ops.
And what that means is like, great, the developers built a whole bunch of code that's fine. And then what happened is that there's a separate group called operations that actually has to make this code run. And then what happens is they discover that this code it's really fine, and it doesn't end up running very well. And what ends up happening is this handoff that you get. And it's when one group goes ahead and passes their material on to another group who's then responsible for dealing with it. And so it tends to turn out you get a lot of handoffs, and it doesn't go that smooth. And so DevOps really came down to, wait a minute, let's talk about how we could actually have these, instead of being two separate groups, let's actually consider whether we should actually make these one group so that the people that are writing the software are actually considering about, hey, what would it take to run this stuff? And so then when Dale's giving his talk about, hey, we actually built monitoring in, the developers might do that because they know that they're actually going to have to monitor it because they're the ones that run it. And then I put a sec in here because this is a big new thing that's coming up, which is, hey, maybe security, they're not just the crotchety old people that stop you from deploying things because that's not secure. Maybe those are people that we should also talk to, because security is one of those things that it's hard to think of later. And so this is one of the things they talked about, and I thought it was kind of interesting because specifically what they're talking about is the big four metrics. And so you're like, wait a minute, DevOps, the big four metrics, those don't sound the same. But what's actually happened is, who's heard of Puppet Labs? Very few people. It's a really cool company, and what they did is they did infrastructure automation, and specifically what they did is they did this absolutely gigantic survey. And if you read this book, like the first 50 pages is about stats and how significant their research is and how they it's really, really boring. But in the end, what they did is they surveyed a whole bunch of companies that have a ton of developers, and what they said is tell us about how you develop and answer a few questions for us, and let's understand whether you're considered a leader in terms of revenue or whether you're considered a laggard, which is also a loser, I guess, would be a better way. But laggard sounds nicer. But the interesting part is what they found is everybody always says that, like, when you're measuring the creative, you're measuring developers, you're measuring designers, you're measuring all these things, you can't measure it. It's impossible. We just hire these people and then we hope we make money. That's really what they said, is there's got to be something you could measure. And what they actually found is they found statistical significance in 3 out of 4 of these, the top 3. The fourth one they included because they're like, it's got to be cool. But the interesting part here is that lead time is one of those things, and you can actually measure that. And so what that's defined as is when a customer says, I need this feature, and it's really critical, and your team says, cool, we agree, how long does it take until that customer's actually accepted that feature? And they have numbers for, hey, what does a good company look like? And they have numbers for what a bad company looks like. And what they've actually found is that in terms of this, if you can improve the lead time, how long it takes from when a customer says they need something to when you actually have delivered it. And it's important that they mention when the customer is satisfied, so not like you shipped it and then the customer wasn't satisfied. It's when they're actually happy with it. And the important part here is that actually not just correlates, but that's causationally related to revenue. So what that means is you can actually find that by decreasing your lead time, it's tied to better revenue. Companies that do this do better, and it's not a correlate. And again, there's a whole bunch of stats on why that is. We're not going to go in there because I fell asleep. But then what happens is deployment frequency. And so you're like, deploy more often is what they're basically saying. And again, this causes revenue to be better. Now let's think about this. The reason that deploying more often is actually reducing batch sizes. And this just makes sense as a whole, because everybody knows that if you try to do one thing that's really small, you're almost always successful at doing something really small. And then as soon as you take on something big, like let's say you want to surprise your spouse and renovate the bathroom this weekend, hypothetically, that doesn't end well, but like if you just took one small piece, it probably would have ended well and you would not be talking about this anymore. That's what they're talking about for deployment frequency, is taking these smaller steps. And as much as that seems like obvious, you can actually measure this stuff, and you can determine that, hey, if we got better at this, this is actually going to cause us to be better, because what it means is we're actually shipping features. And again, this is assuming that you're building features that your customers would actually pay for, which is a separate topic altogether and probably a separate department. But this is one of the things that if you can do that, you can actually tie this to revenue. And the other one is mean time to restore, which this one maybe sounds a little bit more cryptic, but what this means is when stuff breaks, not if, but when, how long does it take you to get back to not broken? And it actually turns out that your customers like it when your stuff works. And the fact that your stuff isn't always going to work because you're going to make changes, the quicker you can get it back to working, again, that's tied in there. And the last one that they talked about, that they said, we couldn't actually go to the level of saying that this causes a change in revenue, but it is correlated. It's when you do make all these changes, what percentage of them are good? So what percentage of the time when you make these changes, this like absolutely copious amount of changes, do you actually cause problems? That's probably actually related. They couldn't prove that it was 100% causational, but they did prove it's correlated. So kind of interesting stuff. And then the bonus for everybody in the room, How many of you are in construction in here? Okay, so not a lot of people in construction. So, how many of you, how many people in the room would identify themselves as blue-collar labor? So what you're going to find is, you're going to find that actually at the end of the day, knowing whether you did a good job is actually a really hard thing for most people in white collar. The thing is that you could always do a little more, and tomorrow the work is all still going to be there. And so what a lot of people have trouble with is there's a couple things that come up. One of them is actually knowing like, hey, how am I doing? And this kind of results in things like imposter syndrome. It results in people not knowing like, how am I doing? And it results in things like, hey, when performance reviews come up, a lot of people are actually quite negative about how they're actually doing. Whereas, if you're building widgets, it's actually quite easy to compare your performance to your neighbor, because did you build more widgets and you do it more consistently? Cool, you're better. At your job, not necessarily as a person. But anyway, the important part is there's a really good metric for you to know, hey, how am I doing? And the important part here is this can actually bring a yardstick to development for you to understand at the end of the day, like, hey, did I do a good job? How's my team doing? How are we doing versus other things, and are we getting better? These are actually some metrics where you as a team can understand, hey, what's going on? Because you don't actually have the same very concrete how many widgets did you build at the end of the day. And this is something that you can do that actually has an effect on revenue. We're not just doing this because this is morally superior. We're actually doing this because it makes a difference. So I thought this was a pretty cool topic. And there's one other book that I thought I would give a shout out to. This is a really fun book. How many of you have read 5 Dysfunctions of a Team? Okay, so The 5 Dysfunctions of a Team is a really interesting book in that it's like a story, and this is not Shakespeare, it's not Darwin, it's not Dickens, it's none of these things. It's not a very exciting story, except for the point is it has a moral, there's a whole bunch of lessons in it, but it's much more readable than a typical business book because it actually is a story. And this is a very similar one, and it's basically this is one of the projects that talks about this idea of DevOps, about, hey, maybe developers and operations don't have to be two teams that hate each other. I do believe that in the end, the security team is still a nightmare, but at the same time, it talks about this concept, and it's actually a fun read. It probably doesn't take too long to read. So if you're interested in what I'm talking about, it's probably a fun book. I'm going to say that if you're not a software developer, maybe you're going to miss some of the jokes, but it's pretty enjoyable. And so that's what I wanted to talk about today. Did anybody have any questions on either of those two? Mr. Talon.
Okay. One of your points was mean time to recover, and it was kind of obviously not like uptime total. What do you think the distinguishing thing is there?
This is not uptime. Exactly. And so what we're talking about here is like, Eric's question is all about like, one of the things you can measure is how long your service is up, like as a percentage of time, or how many minutes in a month is your service down. But the hard part is that doesn't really correlate so well to how often you deploy. And so one of the things you can find is one of almost the most certain ways to have a service that never goes down is to never change it. Because almost all problems come because somebody changed something. And so the easiest way to get super high reliability is don't ever change anything. And that doesn't actually lead to better customer value, and so the problem is that doesn't directly correlate. So again, this is very much related, and so this is saying that we want you to deploy more, but actually the amount of time that it takes you to restore is actually something that makes a big difference, and it also feeds the other metrics, because if it takes you a week to recover from a failure, how likely is it that people are going to deploy very often? The answer is people are scared to deploy, and they're not going to do it very often, whereas if you can make it so that it takes seconds to fix something, people are a little more confident because they can probably fix it before it's a big deal. And so that's where they make the distinguishment here, but it is a very related concept. Cool. Anyone else? Great. Well, then I'm the only person between you and the drinks and the food, so feel free to stick around till 7, and thank you for coming out to Ideas on Tap. We're going to run the 50-50, I think, is it in 5 minutes, John? Yeah, so we've got 5 minutes if you want to buy any more 50-50 tickets, and I'll come up and announce the winners. But other than that, feel free to stick around and socialize. Thank you.